This is problem 1112. Oops, let's get a new page. So 1112. And this is, in this problem, this is a made-up hash function that is structurally similar to SHA. So the problem says, this problem introduces a hash function similar in spirit to SHA that operates on letters instead of binary data. It's called the toy telegraph hash, or TTH. Given a message consisting of a sequence of letters, TTH produces a hash value consisting of 4 letters. First, we divide the message into blocks of 16 letters, ignore spaces, punctuation, and capitalization. If the message is not divisible by 16, we pad it out with nulls. A 4-number running total is maintained that starts with the value 0000. This is input into the compression function for processing the first block. The compression function itself has 2 rounds. So in the first round, you get the next block of text, arrange it as a 4x4 block, and then convert it to numbers, where A is 0, B is 1, etc., etc. Then we add each column, mod 26, and add the result to the running total, mod 26. In the second round, we use the matrix from round 1, rotate the first row left by 1, the second row by 2, the third row left by 3, and reverse the order of the fourth row. Then we add each column, mod 26, and add the result to the running total. So that running total, of course, is going to be the hash value at the end. The new, so the running total is now the input into the first round of the compression function for the next block of text. So we're chaining forward. And then after the final block is processed, convert the final running total back into letters again. And then that's your hash. So we're asked to do 3 things. One is to draw figures comparable to figures 11.9 and 11.10 that show the overall logic and the compression function logic. Secondly, we're asked to calculate the hash function for a 48-letter message, which is I leave $20 million to my friendly cousin Bill. And then finally, we want to demonstrate the weakness of this hash function by finding a 48-letter block that produces a collision with the hash that we did in part B. And the hint here is to use lots of letter A's. Okay, so let's start off first with these diagrams. So we have a message. Which we're going to break into 16-letter blocks, but then we may have to pad the message out. So on the end here, we'll add some padding so that overall this length is a multiple of 16 letters. Okay, and this is in the spirit of figure 11.9 that we're doing this. So then, keeping with the structure of 11.9, we're going to break this up into 16-letter blocks. We'll call this M1, M2, etc. And this will be MN, because we've got n times 16 letters. So each one of these is 16 wide. And then we're going to take each one of them and we're going to pass it into this function, which we'll call f. Now this first one is going to have an initialization value of 0, 0, 0, 0 according to the specification. Then we do this computation inside here, and then we pass the result into the next function block. We'll call this result H1, we'll call this result H2, etc., etc., and then the last one gets passed in here, where this is HN, which is actually our final result, the hash. Now, in the spirit of figure 1110, we can dive into what's going on inside each one of these function blocks. So for each one of them, we have a message coming in. We'll say the ith message coming in. And we have the h value from the previous result. So we'll call that h of I minus 1. And so what happens here, we pass this into a block where we're going to do column addition. And that's, of course, going to be mod 26. This one comes down here. We do rotate rows, and that result will come down here. This also is an input here, and this output, and the output of the rotate rows comes into another column addition, and of course mod 26. And what we get out is the next h value, so hi. So our input to each f function is mi, and our output is hi. Okay, so let's move on to the second part. So part B, we are hashing this message, which is I, and I'm going to write it with no spaces, leave 20 million, and I'm not going to do the whole thing, so I'll just leave it at that. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's enough to do the first block. Okay, so what we're going to do is we're going to put this into, we're going to arrange this into a 4x4 block. So for example, this would be I, L, E, A, V, E, T, W, E, N, T, Y, M, I, L, L. So now I have the first block, so that's this guy right here. And what I want to do now is I want to convert this into numbers. So I is 9, L is 12, I believe, E is 5, A is 1, V, let's see, W, X, Y, Z, so V must be 22, E again is 5, T, N, O, P, Q, R, S, T, so that'd be 13, 14, 15, 16, 17, 18, 19, I believe that's 19, W, X, Y, Z, so that would be 23, E is 5, N is 14, T is 19, Y is 25, M is 13, I is 9, and then L is 12, and L is 12. Okay, so that's just converting that where A is 1, B is 2. No, you know what? I think I'm supposed to do A is 0, so all these are off by 1. So let me just rewrite it. Copy it, move over to a new page. I'll paste that in, and then let me just fix these values. So it's actually 8, 11, 4, 1, 21, 4, 18, 22, 4, 13, 18, 24, and 12, 8, 11, 11. Okay. And our running total, which is our initialization, starts off as 0, 0, 0, 0. Okay, so the first thing we're going to do is our row-wise addition. So I can just basically add up all of these rows. And of course we want to do this mod 26. So this is 21, and 8 is 29, and 4 is 33, 43, 44, 45. I'm just going to write the totals down for now, and then we'll do mod 26. 8 and 13 is 21. And 11 is 32, so this is 36. And then we have 18, and 18 is 36, plus 11 is 47, plus 4 is 51. And then we have, let's see, 22 and 11 is 33, 53, 57, I think that's 58. Okay, so now we do mod 26. So let's see, 26 goes into 45 one time with, that would be 19 left over. So this goes to 19. This is 10. And then 51, that is 51 minus 26. That's 25. Wait a minute. Is that right? Yeah, that's right. 25 and 58. So 26, 52, so 6. Okay, so I believe those are the mod values. And then we're going to add those to the running total. So now the running total becomes 19, 10, 25, and 6. Okay, and then we take this matrix and we do the rotations. So we're going to rotate this. So this matrix is going to come down here. And we rotate this is a left rotation. We rotate the first one by 1. So this is going to be 11, 14. Oh, I'm sorry, 4. 11, 4, 1, and 8. And then the second one gets rotated by 2. So we have 18, 22, 21, and 4. And then the next one gets rotated by 3. So we have, oh wait, did I make a mistake there? Should be 1, 2. No, that's right. Okay, so this one gets rotated by 3. 1, 2, 3. So it's 24. 2, 3, 24, 4, 13, and 18. And this one just gets reversed. So it's 11, 11, 8, and 12. And now we're going to just do the same thing we did before. We're going to add these up, mod 26, and add that to the running total. So I'm going to use my calculator now. We have 11 plus 18 plus 24 plus 11. That looks like it's 54. And we have 4 plus 22 plus 4 plus 11. So that's 31. Then we have 1 plus 21 plus 13 plus 8, and that's 43. And then we have 8 plus 4 plus 18 plus 12, and that's 42. We take this mod 26. Let's see, 26, 52. So this would be 2. 31 minus 26. This would be 5. Then we have 43. That's 17. And so 42 would be 16. And then we add these numbers to the running total. So this would be plus 2, plus 5, plus 17, plus 16. And so this gives us 21, 15. Let's see, this is 35 plus 7 is 42. And this is 16 plus 6 is 22. And then, of course, we take this mod 26. So we have 21, 15, 16, and 22. So there's our new running total. Okay, and then so this would be the input to the next block. We would take the next set of letters, and we would feed them in, and we just continue to do this. So clearly, if you can write a computer program to do this, it would be way easier. But that's how I would recommend you get it done. The third part, then, we want to try and create a collision, and the hint that we're giving is to use a lot of A's. So if you write a computer program to do this, it should be pretty easy to iterate on some inputs and figure out how to get a collision to occur. So I'm going to leave that part to you.